Hello, this is Professor Keene. Welcome back to Introduction to Astronomy at Wisconsin Lutheran College. We've been exploring Aristotle's book on the heavens, and right now we're moving into Chapter 3 of A Student's Guide to the Great Physics Texts. This chapter is called Harmony and Complexity. The reference here is Aristotle's On the Heavens, Book 2, and in this chapter we talk about Aristotle's chapters 7 through 12 in his book On the Heavens. First of all, I call this chapter Harmony and Complexity because in this lecture, or this series of lectures, I'm going to talk about the motion of the heavens and how this motion is, in a sense, both simple and harmonious on the one hand, and also at the same time very complex or complicated. And these are the kind of issues that Aristotle is going to be wrestling with in this series of chapters. What we're going to do is we're going to address about one question in each of Aristotle's chapters. So chapter 7, for example, deals with the question, what are the stars made out of? And in chapter 8, he addresses what is the motion of the stars, specifically what is the cause of motion. And likewise with chapters 9, 10, 11, and 12. So let's start out with Aristotle's chapter 7 and ask, what are the stars made of according to Aristotle? And the answer is really not obvious by simply looking at them. I know you've heard, since you were young, that the stars are huge balls of fire, perhaps undergoing nuclear fusion reactions. But this isn't obvious by simply looking up at the sky. After all, they just look like little dots of light. So from a strictly empirical perspective, from the point of view of someone standing here on Earth, what can we say sensibly about the composition of the stars? And the interesting thing is that they're moving, right? And many things that we see moving are in fact animate. Animals, in fact, we call them. So if you see something, if you're hiking through the forest and you see something move out of the corner of your eye, your immediate thought is, oh, there must be an animal, perhaps a squirrel running through the underbrush over there. So the question that Aristotle asks is, might these stars be animate? He's eventually going to get to that question. Aristotle answers, however, that the stars, he believes, are made of this fifth substance called ether. Remember, this is the fifth element. The four other elements are earth, fire, air, and water, according to this ancient and traditional periodic table. Why did he think that they are made of ether? Well, it was by process of elimination. So the other four elements, at least from from the perspective of day-to-day experience, undergo straight line motion. Earth and water fall straight down. Fire and air rise straight up. And since the heavens appear to be going in a circle around us day after day after day, they must be made of a fifth element. They are not fire, as some had taught at the time of Aristotle. They're ether, rather. They're not fire, but they do create heat by virtue of their motion. He's going to argue that the stars are fixed to this large celestial sphere rotating about us, and moreover that the planets, the sun, and the moon are fixed to these large celestial spheres, all made of ether, and as they rub past each other and as they rub past the atmosphere of the Earth, they do indeed create heat by motion. After all, when things rub together, they produce heat. Now let's move on to his chapter 8. In this chapter he asks, what is the motion of the stars? More specifically, what is the cause of the motion of the stars? Now, here is the interesting thing. We do see the stars moving day after day in the form of certain constellations, the Big Dipper, Sagittarius, and so on. They rise and set every night in the same configurations. For as closely as anyone is able to tell, they look like they're forming the same configurations or shapes in the sky. And we have claimed that these stars are in fact fixed to an enormous celestial sphere that rotates around the Earth once per day. But in this chapter, Aristotle asks, are there other possibilities? Are there other accounts of the motion of the stars? And he lists three possible answers, or three possibilities. The first possibility that he considers and then rejects is the possibility that both this celestial sphere and the stars themselves that populate it are truly at rest. He answers, this possibility is impossible, in fact. Why is that? Well, if the Earth itself is at rest, as we have been assuming, then something must be moving. Either the sphere is moving or the stars are moving. In order for us to have the perception of the motion of the stars, something has to be moving. So if the Earth's at rest, it's impossible for the celestial sphere and the stars themselves to be truly at rest. The second possibility that Aristotle continues is perhaps the celestial sphere rotates around us once per day, but the stars themselves also move over the surface, I suppose the inner surface of this sphere, crawling around maybe like ants or some other living creatures on this rotating sphere. It's almost as if you're watching ants run around on a rotating record player, where the record is spinning and the ants themselves are also crawling around. Now, why is this impossible? Well, Aristotle argues that this is extremely unlikely. Why is that? Because if the stars had their own ability to move on their own, it would be unreasonable for them to always maintain the same configuration day after day after day. Orion should have a different shape night after night if the sphere was rotating around and also the stars were moving independently on this sphere. It would be too coincidental for all the stars to occupy the same configurations day after day. So he says this is not a reasonable explanation of the experimental observations. Perhaps, on the other hand, the celestial sphere, and this is the third possibility, perhaps the celestial sphere itself is at rest, but the stars are themselves moving about on it. Once again, they have independent motion, independent of this sphere, but the sphere itself is at rest. Well, for very much the same reason he rejected the previous possibility, he rejects this possibility. He says it would be too coincidental for all the stars to have independent motion of themselves and yet to maintain the same configuration night after night. Now notice all these might seem to be strange possibilities to you, and in fact he finds them strange too, and yet he takes them seriously enough to argue against them. So what's the solution he comes up with? Well, the only other possibility, he says, is if the celestial sphere is rotating about us once per day. That's the daily or diurnal motion of the sphere, and the stars themselves are fixed to this celestial sphere. That is Aristotle's cosmology. That is his picture of the motion of the stars. Now, one other thing that he picks up here, this is in chapter 9. So we just finished chapter 8 of Aristotle's text. What about in chapter 9 of book 2? Here he addresses a very interesting question which you may not have thought of, but has far-reaching implications for astronomical thinking after the time of Aristotle. The question is, do the stars make some kind of noise when these spheres rotate around? After all, if these spheres are rotating and the stars, and as we'll see in a moment, the planets and the sun and so on are fixed to these spheres and they're rubbing around, going around each other, rubbing against each other perhaps, wouldn't they be making some kind of noise? After all, when things rub against each other, they make noise. So it's not such a preposterous idea given the worldview that he's advocating. In fact, there were earlier thinkers, notably the Pythagoreans, which we've mentioned before. You probably heard of Pythagorean theorem, a squared plus b squared equals c squared for a right triangle. They didn't just do that. They were kind of a semi-religious philosophical cult that preceded the time of Aristotle, and Aristotle dialogued with their followers. Anyhow, the Pythagoreans argued exactly that these spheres were rotating around, and as they did so, they created kind of a symphony of sound. Each sphere hummed with a particular note that was appropriate to its size and shape. Altogether, these spheres, as they rotated around, created a harmony of sound. Why, though, can we not hear this? After all, if there is a symphony going on, shouldn't we hear it with our ears? Well, the Pythagoreans argued that since we have been accustomed to this since our birth, we are unable to hear it. It's almost like we've learned to ignore it over time. Now, is this a possibility? Aristotle considers this idea of the Pythagoreans, the idea of the harmony of these spheres, and says, no, this is not possible. Why not? Well, he says, even if there was this sound that we've grown accustomed to and so can't hear with our ears, these sounds would still produce some sensible effects on the nature around us. Just like when there's an explosion, a loud noise, it's not just our ears that hear it, but things shake, leaves wobble, trees fall over. There would be some kind of manifestation of this sound if it was really there. And since we don't see any of these manifestations of this harmony of the spheres, it's reasonable to conclude that this is not there. They are not making any noise. Now, how can such motion of rotation of these spheres happen without any noise? This is where Aristotle says, and I'll read a short quote. He says, "It is as if nature had foreseen the harmful effects such noise would have on the earth." I'm paraphrasing. "It's as if nature had foreseen the harmful effects such a loud noise would have on the earth, and was then constituted in a way so as to preserve the earth." So it's not making this noise because it's some kind of design built into nature that would preserve the integrity of the earth, you might say. I find these ideas interesting. I had never thought about this before, that the planets would be making noise. The Pythagoreans, as I said, accepted this idea. Aristotle says no. But interestingly, this idea will be picked up again later by the Lutheran philosopher and astronomer Johannes Kepler. And he writes a book called On the Harmony of the World, Harmonies of the World, or Harmonies of the Spheres, where he also believes that he's a heliocentrist, by the way. He believes the sun is at the center and the planets are orbiting around the sun. He didn't believe in actual physical spheres carrying the planets around the sun, but he did believe, nonetheless, that they were orbiting around according to some plan, some archetypal plan that God the Creator had made them orbit in, and these orbits themselves correspond to certain kinds of musical notes. So just like in music, certain notes are reflective of certain frequencies of vibration, and certain combination of notes sound good together, like chords or particular notes separated by an octave or a fifth. So too, Kepler argued, the planets, as they're orbiting around the sun, have certain frequencies, and those frequencies, at least to the mind, create a symphony of sounds, if not to the ears. So this is a theme that Kepler picks up later on, this Pythagorean idea of the harmony of the spheres. We'll come across this when we read some Kepler. Okay, so tell you what, we have finished up through chapter 9 of book 2 of Aristotle's On the Heavens. Next time we'll talk about chapter 10, so let's take a short break.